right, solving quadratic equations by factoring. So we're going to look at a quick review of your grade 10 factoring techniques, but we have to do it quickly because we've got lots of stuff to do here today. And then we're going to talk about solving quadratic equations with zero product property, checking solutions by substitution, and solving a quadratic equation in non-standard form. So your grade 10 stuff, which you should already know, just a quick refresher here, 4 types of factoring we're going to see here. First one is common factors. So if I have a binomial with common factors like 3 is a common factor and x is a common factor, if the first term is negative, I have to take out the negative, and then I divide both terms by my common factor, which is negative 3x, and I get x minus 4. Second type of grade 10 factoring we have is called product sum. So we have an x and an x, and what we're looking for is 2 factors of 24 that have a sum of negative 11. All right, so in that case, we're looking for 3 and 8 because they add up to 11 and multiply to 24, and they both have to be negative to add up to negative 11. Okay, we only use product sum when we have a leading coefficient that's just 1, so be careful with that. It doesn't always work. We'll see in a sec. We have difference of squares. So for a difference of squares, if you remember the algorithm you learned after we saw why this works, we have take the square root of each of those 2 things that are perfect squares. So 5x is the square root of 25x squared. 9 is the square root of 81. Take their difference and their sum, and we're done. That's an easy one. Decomposition. This is the most involved method. It takes a bit of algebra to do this one and some space. So we'll make a little more room here. There's other ways to factor this, but decomposition is the most commonly used method. So that's why I'm going to review this one. So first of all, this is a non-unit coefficient. We've got something in front of x that's not a 1. We can't just use product sum for this trinomial. So what we do is we multiply the outside numbers together. 3 times 6 is 18. And then I need 2 factors of 18 that'll add up to the negative 11 we have there. So they're going to be negative 2 and negative 9. So I split my negative 11x into those 2 things, and I keep my 2 outside terms exactly as they were. So I haven't changed the value of my expression. I just split up my middle term. Now what I'm going to do is what we call group factoring. So common factor in each of these 2 pairs. For the first pair, I have a common factor of x. Dividing both of those terms by x leaves me with 3x minus 2. And for the second pair, I have a common factor of 3. Since the first one is negative, I take that out, leaving me with 3x minus 2. Now I have 3x minus 2 and 3x minus 2 as a common factor. And if I divide that out of each term, the first one has an x, the second one is a minus 3. And that's grade 10 factoring, done at rapid fire. All right, so now what we do is we use our factoring techniques that we are assumed to already know, and we use them to solve quadratic equations along with the zero product property that we touched on in the last unit. Let's put all that together. So I want to solve this quadratic equation. So what I'm going to do is I'm going to say x squared minus 3x minus 28 can be changed from standard form into factored form. How do we do that? Well, 2 factors of 28 that add up to negative 28, be negative 7 and positive 4. Now I've got factored form. So zero product property tells me that if a times b equals 0, then a is 0 or b is 0, or maybe they're both 0. But either way, we look at both cases. So either x minus 7 equals 0 or plus 4 equals 0. If x minus 7 equals 0, then x is 7. And if x plus 4 equals 0, x is minus 4. And for this one, we have common factor here of x. So we take that out. We've got x times 5x plus 3 equals 0. So that means that either x is 0 or 5x plus 3 equals 0. If x is equal to 0, there's not much more we can do. But if 5x plus 3 equals 0, 5x would be negative 3, and then x would be negative 3/5. Okay? So we've got 2 roots for that quadratic equation, and 2 roots for this one. Next. Once we have the solutions for a quadratic equation, we can check them to verify that they are correct by substituting them back into the quadratic that we start with. So if I take that x equals 7 and plug it in for x here, on the left-hand side, I'm going to get 7 squared minus 3 times 7 minus 28. So that's 49 minus 21 minus 28, which equals 0. Which also happens to be the right-hand side of that equation. So what do you know? Left side equals right side. It works. If we try negative 4, Left-hand side here is going to be negative 4 squared minus 3 times negative 4 minus 28. So that's 16 plus 12 minus 28. Yep, 0. So that one's also equal to its right-hand side. So that one works. Over here, if we try plugging 0 in, our left-hand side is going to be 5 times 0 squared plus 3 times 0. Yep, 0. That one works. And we'll try the last one, negative 3/5. 5 times negative 3/5 squared. Woo, squaring a fraction. We can do it. And 3 times negative 3 over 5. What are we going to get? Let's see. 5 times 9 over 25. Square the top and the bottom. Minus 9 over 5. 5 over 25 reduces to 1 over 5. So I got 9/5 minus 9/5, which is 0, which is in fact our right-hand side. So that one works. Okay, that's just a quick rundown of how we verify. What happens if we get a quadratic that's written in this mess? Well, same idea, we just got a little extra work to do. Start off by expanding out anything you have to expand. So all I did here was I used distributive property and multiplied 2x by both of those terms. Then I'm going to collect all of my like terms on one side. And if you have to choose one side or the other, it doesn't really matter. But I always encourage my students to choose the side that keeps your squared term positive. So I'm going to kick everything over to the right here. That's going to give me a 2x squared minus x squared is just an x squared. And then negative 10x plus 7x is going to be negative 3x. Okay, so we've got a common factor of x here. And then x minus 3. So by zero product property, x is going to be 0, or x minus 3 equals 0, which would mean that x equals 3. And those are our roots. All right. So it's a good idea to review your grade 10 factoring. If you haven't got that down cold, you're going to get in trouble now. So it's time to go back and review all that. So we use the zero product property to create two simple linear equations to solve. We can always substitute them back in to check that we're right. And when we solve a quadratic in non-standard form, just rearrange the equation to standard form and then go for your factoring. Good luck. Hope that helps.